Airbus SE is one of the largest aircraft manufacturers in the world, formed in the late 1960s through the merger of several European aircraft manufacturers, putting passenger, cargo, and military transport aircraft under the Airbus brand. The manufacturer works on three different concepts: for turbojet engine design, turboprop design, and mixed-wing design. Before we continue, please subscribe to the channel and ring the notification bell so you don't miss our next video. Now let's continue ahead in today's topic. Airbus plans to launch a hydrogen-powered zero-emission aircraft in 2035. As Airbus CTO Grazia Vittadini said in Toulouse, the first demo model should be designed in just under 3 years and will take off for the first time in 2025. The pressure on the aviation industry to reduce CO2 emissions is increasing. In addition to the effects of the COVID-19 pandemic, this is one of the biggest challenges for manufacturers. With the previous response to reducing gas turbine consumption by increasing rotors, the EU's climate goals no longer seem achievable. At the same time, the technology reaches its limit due to the extremely high speeds of the rotor ends. In the recent past, Airbus relied primarily on electric aircraft powered by electric motors or hybrid systems. The company has now switched to hydrogen because it's incomparably lighter than batteries, said Glenn Llewellyn, vice president of the Zero Emission Project at Airbus. The energy density is as high as with kerosene with significantly lower weight. At the same temperature, however, the volume of hydrogen stored is 4 times higher. That's why we're working on the use of liquid hydrogen, Vittadini said. It has a significantly smaller volume, but must be cooled to minus 253 degrees Celsius. Rocket manufacturer Ariane Group, the creator of the Ariane rocket, is already collaborating with the utility company ENGIE and Airbus on the topic of hydrogen liquefaction. Chief engineer Jean-Brice Dumont explained that Airbus works on 3 different concepts: turbojet design for 120 to 200 passengers with a range of over 3,700 kilometers, capable of flying on transcontinental routes and modified by a gas turbine engine running on hydrogen, not jet fuel, by combustion. The liquid hydrogen will be stored and distributed through tanks located behind the rear airtight baffle. A turboprop design for up to 100 passengers using a turboprop engine instead of a turbofan engine, and will be powered by burning hydrogen in modified gas turbine engines that could travel more than 1,852 kilometers, making it an ideal option for short-haul travel. The mixed-wing hull concept for up to 200 passengers, in which the wings merge with the main body of the aircraft with a range similar to that of the turbofan concept. The extremely wide fuselage opens up many possibilities for hydrogen storage and distribution, as well as for the layout of the passenger compartment. Which of these 3 concepts will be the first to hit the market is still unclear, Dumont said. Vittadini added that hydrogen can be turned in gas turbines such as kerosene. Instead of poisonous exhaust gases, water vapor is formed. However, wires in combustion chambers must be designed differently. The idea of replacing kerosene with hydrogen is not entirely new. Until now, manufacturers have given it up because a significant part of the hull, about a third, must then be reserved for the tanks. This was unacceptable as far as the logic of pushing more and more passengers into the hulls was applied. The coronavirus pandemic has triggered a rethink though. No one knows if as many passengers will ever be transported as in the recent past. And when planes are left half empty anyway, so is the acceptance of new technology that takes up more space but is clean. Both managers point out that Airbus cannot make the necessary technical developments on its own. After all, hydrogen-powered planes are truly emission-free only if hydrogen is not generated in the conventional way, but with the help of renewable energy. Although this is possible, the necessary large-scale installations of the required quantities do not yet exist. They must be created by gas producers such as Air Liquide or Linde, or by oil companies. In addition, Airbus depends on cooperation with engine suppliers. Llewellyn promises Airbus alone needs several billion euros in investment. We will do it. To meet these challenges, airports will need significant infrastructure for hydrogen transport and refueling to meet the needs of day-to-day operations. Government support will be key to achieving these ambitious goals, with increased funding for research and technology, digitalization, and mechanisms that promote the use of sustainable fuels and fleet renewal to enable airlines to retire older and fewer environmentally friendly aircraft earlier. The French state supports the development of low-carbon flights and believes that the development of Airbus on a hydrogen-powered aircraft is the best response to the crash of aviation, said meanwhile the French Minister of Transport Jean-Baptiste Djebari on LCI TV Monday. The new designs are the result of a joint research project that Airbus launched with EasyJet last year to develop hybrid and electric aircraft. While hydrogen has been discussed in the aviation industry since the 1970s, it remains too expensive for widespread use. Proponents say infrastructure investment and growing demand will cut costs. Most of the hydrogen used today is extracted from natural gas, which creates carbon emissions. Airbus said the hydrogen used for aviation would be produced from renewable energy and extracted from water by electrolysis. This is a carbon-free process if powered by renewable energy, but is currently more expensive. Currently, hydrogen is most often obtained from fossil fuels such as oil, gas, or coal. Green and yellow hydrogen must be made by electrolysis from nuclear energy or hydroelectric power plants. The huge investments in infrastructure will be needed to make hydrogen planes a reality. The first results of the development plan are expected by the middle of next year, and the final concept will be chosen by 2025. The possibility of designing an electric aircraft in the future is not excluded.